Tableau isn't just about building charts. It's also a powerful analytical engine with its own scripting logic. With the help of calculated fields, you can go far beyond basic visuals. Want to extract a portion of a string? Done. Need to flag rows that contains a specific keyword, for example ph in this case? Easy. Or maybe you want to calculate important business metrics like profit margin and break them down by region, segments or product categories? For example, we'll create a logical visualization based on profit margin percentage and assign color codes to subcategories categorized as low, average or high profit margins. So the number of business questions that you can answer using calculated fields is virtually limitless. They unlock a whole new level of insights from your data. This way, Tableau empowers you to perform detailed data analysis by manipulating and transforming data exactly as your use case demands. This is just the starting point for calculated fields. As we move forward, we will be using them extensively throughout the rest of the course. And along with calculated fields, I'll also introduce you to two more important concepts that are context filters and hierarchies. You've already seen a glimpse of hierarchy when we used the order date field to drill down the visualization from year, quarter to month to day. Great. Now before we dive in, let's go over the agenda and highlight the key topics and action items we will be covering in this video. We'll begin by understanding the role of context filters in uncovering meaningful business insights. To see this in action, we'll identify top 5 best-selling phones from the Superstore sales data, first using regular filters and then with a context filter to see the difference it makes. Next, I'll walk you through what hierarchical relationships mean in Tableau, how Tableau automatically recognizes and uses them for certain data types, and how you can create your own hierarchies using multiple fields to simplify analysis and make data exploration more intuitive. Next, we will deep dive into the world of calculated fields, starting with a customer support scenario, where we will retrieve user information based on known partial details like order ID or a fragment of the customer name. After that, to demonstrate a more fundamental use of calculated fields, we'll tackle a simple business problem, identifying the minimum and maximum sales for each product subcategory. The problem seems simple, but we will do it with the help of calculated fields to gain a fundamental understanding of the concept. Next, we will cover one of the most important aspects of calculated fields in Tableau, learning how to correctly formulate basic calculations like profit margin percentage. I'll walk you through both correct and incorrect approaches with visual examples, so you can clearly see how they impact the final computation. Once you understand the logic and how Tableau does the aggregation, we'll use the calculated fields to build logical visualization that help us track profit margin metric for different product subcategories at a glance. And finally, we'll wrap up the calculated fields section by creating one of the advanced and visually appealing chart called the Waterfall Chart. Here, this chart helps us visualize the running total of sales for each product subcategory and understand their individual contribution to total sales. Just like the name suggests, it resembles a waterfall cascading down a mountain, stepping over the rocks as it flows downhill. Looks like we have some exciting topics lined up for this video. So let's get started by first understanding what a context filter is and why it matters. To understand context filters, let's start with a simple business question. Which 5 phone models have the highest sales? Now take a moment to think why identifying top 5 phone models is important for the business. Because identifying the best-selling models help companies focus their marketing and inventory strategies on high-demanding phone models. And it also reveals customer preferences and emerging market trends, right? Now with the data snapshot in front of us, let's try to identify which columns or fields we will need to conduct this analysis effectively. Since we are focusing on phone models, and if you have been following along with this dataset throughout the course, you will recall that phone models fall under the product subcategory column. So the first field we'll need is the subcategory column. Similarly, we'll extract the specific phone model name from the product name column. And finally, pull the sales figures from the sales column. And to get started with the analysis, we'll place the subcategory field into the row shelf. Our final view should look like this. Under the phone subcategory, we'll see the top 5 phone models listed in descending order based on their sales. Seems easy, right? Before we switch over to Tableau to build this view, let's quickly go through the steps that are needed to get started with this analysis. We'll start by placing the subcategory and product name field onto the row shelf and the sales field on the text card to display the sales figure for each subcategory and product. Let's start by setting this up first, then we'll focus on filtering for the top 5 phone models in the next step. I've already set up a fresh Tableau session and imported the Superstore sales data. As we discussed, the first step is to drag and drop the subcategory and product name field onto the row shelf. Once we drop the product name adjacent to the subcategory in the row shelf, this warning prompt appears. It's just because there are too many product names to display. For now, go ahead and choose the first option, Add All Members. Next, we will drag the sales field onto the text mark on the visualization canvas. Let's also sort the products in descending order based on their sales value. You can do this by clicking on this descending sort button in the toolbar. Also, let's increase the width of the columns for better readability of the product names and subcategories. Now, as you can see, after sorting the data in descending order, the highest selling products will appear at the top for every subcategory separately. For example, for this accessory subcategory, the product name Plantronics CS510 has the highest sale of around $11,000. And for the appliance subcategory, the product name Honeywell NV Care has the highest sale of around $11,000. So for every subcategory, the highest selling products will appear at the top. I hope this makes sense. Once we have this foundational setup in place, let's revisit our original question and identify the next step needed to move forward. Since the question specifically focuses only on the product subcategory, we'll begin by filtering the subcategory field to only show phones. To do this, we'll start by dragging the subcategory field onto the filters pane and select only phones from the list of options to focus only on phones subcategory. And now to filter the phone models and display only the top 5 based on sales, we'll drag the product name field onto the filters pane and then choose to display top 5 products by sales. Now with this logic in mind, let's go ahead and perform these filtering steps in Tableau to complete this analysis. First, drag the subcategory field onto the filter shelf and select only the phone subcategory. To do this, first click on None to deselect all the options and then scroll down to check only for the phones and then click on OK to apply the filter. Once the filter has been applied, you'll notice that only the phone subcategory and its associated products are displayed in the view. Next, we need to filter for the top 5 products based on their sales values. To do this, drag the product name field onto the filter shelf and let's take a look at the available filtering options. When this filter window opens, the first radio button you will see is Select from List. Now ask yourself, do we need to manually pick products from this list? The answer is no, because we want Tableau to dynamically select the top 5 phone models based on their sales value. And that's why to do this dynamically, we'll switch to this top tab and choose the second option by field. Here you will see 4 drop-downs. Let's walk them through one by one. In the first drop-down, you can choose between top or bottom. We'll leave it and set to top as we're looking for top 5 products. In the second box to the right, enter the number 5 since we are looking for the top 5 items. The third drop-down determines which field we are ranking by. And since we are filtering based on sales, we'll leave it as sales. The fourth drop-down sets the aggregation method And because we want to filter the top 5 products by the total sales, we'll keep it as sum. So essentially, the only change we are making here is updating the number from 10 to 5. This tells Tableau to filter for the top 5 products based on the total sum of sales. Once done, click OK to apply the filter. And as soon as you click OK, you'll notice that the view goes blank. It looks like everything just disappeared. So what happened? Where did we go wrong in our logic? Let's try to debug this. Well, if we try to remove this top 5 product filter we just applied by dragging it out, the original view comes back, right? But when this top 5 product filter is active, we are not getting the expected result. So something is not right with this top 5 product filter. Let's take a moment to understand why this is happening. So to experiment, instead of removing this top 5 product filter, I'll remove this subcategory filter that is specifically set to show only phones. And the moment I take out this subcategory filter, with only this top 5 product filter active, you can see the view updates to show top 5 product by sales across all subcategories. Now I want you to take a closer look at the subcategory column. You'll notice that none of these top 5 product belongs to the phones subcategory. They are either from binders, chairs, copiers or machines. That's why when both these filters were active, one filtering for phones and other filtering for top 5 products overall, Tableau didn't return any results. And that makes sense too, because under the top 5 products by overall sales, there are simply no items from the phones subcategory. Getting the hang of it? I hope everything's making sense so far and you are able to follow along clearly and see why we are getting the blank view. But one thing is very clear from this observation, that this top 5 product filter is taking priority and filtering the data before the subcategory filter is being applied. Since none of the phone models are among the top 5 product by sales, applying the phone subcategory filter afterwards result in an empty view, because there's simply nothing left to display. So simply filtering the subcategory for phones and then applying this top 5 product filter based on sales won't give us the desired output. That's because this top 5 product name filter is applied first, which is potentially pulling products from other subcategories, which can lead to incorrect or empty results. So what we need to do now is set a context for this top 5 product name filter. In other words, we need to explicitly tell Tableau to first filter the data only for the phone subcategory and then apply the top 5 logic within that filtered context. In Tableau's terminology, this means we are setting the subcategory equals to phone filter as a context filter, ensuring that it is applied first, and then does Tableau apply the top 5 product by sales filter within that predefined context. I hope you've got a clear theoretical understanding of what we are trying to achieve here. And the good news is, applying a context filter in Tableau is super easy. All you need to do is to right-click on this subcategory equals to phone filter and select this 5th option from the top, Add to Context. And just like that, Tableau now filters the data correctly to show the top 5 best-selling phone models based on their sales values. And the filter that is set to context will now appear as a gray shade in the filters pane. So remember, once you understand the underlying logic and flow, implementing it in Tableau is incredibly quick and straightforward. This is the final view we are aiming for. And now you're free to convert this into your preferred visualization. Simply head over to the Show Me tab and choose the chart type that best represents this insight. From this table, it looks like Samsung Galaxy Mega 6.3 leads in overall sales, followed by iPhone 5 and so on. And finally, let's go ahead and rename this sheet to Context Filter to keep our workbook organized and easy to follow. So that wraps up our first topic, context filters. Now let's move on to another cool and simple feature in Tableau, which is hierarchy. To understand what a hierarchy in Tableau is, let's start with a quick refresher on the date data type, which Tableau automatically recognized for this order date field. Now imagine you are given a hypothetical task to analyze sales across different levels of time. For example, how sales look at the year level, how do the sales perform quarter by quarter within each year, what's the trend month by month within each quarter, and finally, how do sales vary day by day throughout the year. This kind of layered analysis is exactly what hierarchies come into play. To see hierarchy in action, in Tableau, we can drag the order ID field onto the column shelf and sales measure onto the row shelf. These steps produce a simple bar chart displaying the total sales for each year. Since this order date is recognized by Tableau as a date data type, it automatically understands the underlying hierarchical structure of dates. That's why when you click on this plus icon next to the year pill on the column shelf, the visualization seamlessly drills down from year level to year and quarter level, right? It now resembles a group bar chart where each group represents a year, and within each group, you will see bars for each quarter. This is the power of hierarchies in Tableau. They allow you to dynamically zoom into more granular levels of your data with just a click. Here we have moved from year to quarter, but we can keep going deeper if needed. So what do you think will happen if I click on this plus button, this time next to the quarter pill? Exactly, you will drill down one more level in the hierarchy, moving from year quarter to year quarter and month level. Now you will be able to see monthly sales data starting from January 2019 till December 2022. And if you click on this plus button again next to the month's pill, Tableau will take you to the most granular level, to the day level. Although this will require quite a bit of right scrolling in order to view all days across 4 years, but you get the idea. Each click takes you deeper into the hierarchy, offering more detailed insights. Now I would like you to follow the same step in your Tableau workbook. First drag the order date to the column shelf and sales to the row shelf, and then keep clicking on this plus icon to drill down step by step and explore the hierarchy all the way to the day level. This simple hands-on practice will give you a clear understanding of how date hierarchies work in Tableau. Now what if you want to create your own hierarchy in the dataset? Take a moment to scan through the available fields and think about it. Aside from the dates, which other fields might follow a natural hierarchical relationship that we can leverage in our analysis? Let's see if you spotted them correctly. So yes, there are two clear hierarchical structures in this dataset. First is category, subcategory and product name, and the second is country, region, state and city. The second one is classic geographical hierarchy, moving from national to local levels. Both of these hierarchical relationships can be turned into custom hierarchies in Tableau. For example, if you want to analyze sales using the geographical hierarchy we just identified, we first need to create that hierarchy in Tableau. This means arranging the fields in correct order with country at top, followed by region, and then state, and finally city. Once this hierarchy is created, we can simply drag this newly created hierarchy onto the column shelf and place the sales field onto the row shelf. You will be able to drill down through each level of this hierarchy from country to city and uncover deeper and more granular insights. Alright, now let's quickly see how to create this hierarchical relationship in Tableau. I'll show you exactly how to set it up and recreate this kind of plot, so you'll be ready to start building your own custom hierarchies in no time. In Tableau, first create a new sheet and rename it to hierarchy. Now as we discussed, to create a custom hierarchy, we need the fields such as country, region, state and city. So let's first select all these fields, hold down the control button on your keyboard and click to select each of these 4 fields one by one. Once selected, right click on any one of them and go to the last option in the menu, which is hierarchy, and then click on create hierarchy. A prompt will appear asking you to name the hierarchy. You can choose any name you like. I'm naming it geographical hierarchy for this example. Once done, click OK. Now notice at the top of the data pane, you will see this newly created field, Geographical Hierarchy, and under this you will see all these 4 fields: city, country, region and state. However, this relationship isn't in the correct order just yet. So to follow proper hierarchy, we should be placing the larger geographic level first. To fix this, simply drag this country to the top of the list, followed by region and then state and finally city. Now the hierarchy looks properly structured and we are good to go. Now let's see this hierarchy in action by analyzing sales across country, region, state and city level, all within a single visual. So start by dragging the geographical hierarchy field onto the column shelf. Once you drop this hierarchy to the column shelf, notice the pill on the column shelf. There's a plus symbol in front of the country pill. This indicates that it's no longer a regular field, but a part of hierarchy. This plus symbol tells us that this field can now be expanded into deeper levels, just like we saw earlier with the order date hierarchy. I'm adjusting this column width a bit for better visibility. Next, drag the sales field onto the row shelf. This gives us a bar chart showing the total sales at the country level. And since our dataset only includes the United States, you'll see a single bar representing the total sales for the country, which we know is around $2.29 million. Now it's time to drill down through the hierarchy in a bar chart. So go ahead and click on this plus button next to the country pill. This reveals the sales distribution across 4 regional levels. Then click on this plus button next to the region pill to expand further and see sales broken down by state. Now if you want, you can even go deeper by clicking on this plus button next to the state pill to basically view sales at the city level. But since that might be too much detail for now, let's remove this city pill to keep things clean. And finally, to make this view more intuitive, click on this second sort button in the toolbar to sort these bars in descending order of sales, showing the highest performing areas first in the list. Cool? I'll leave the rest of the formatting for you to explore on your own. And that's how you can create your own custom hierarchies in Tableau. It's simple and super useful tool for multi-level analysis. So that's it for the hierarchies. Now let's move forward and dive into the world of calculated fields, which is one of the most powerful tools in Tableau for custom analysis and deeper insights. In short, calculated fields unlock the ability to perform custom calculations, whether it's using built-in functions, writing your own formulas, or transforming data to a specific use case. They give you full control over your data, allowing you to manipulate and transform it as needed. And like any other skill, the more you use calculated fields across different scenarios, the better you will get at it. So to give you a solid introduction, we'll explore them through 5 different use cases, each showing a unique application of calculated fields. So to get started, let's jump into a first business question and start having some fun learning about calculated fields. I'm starting with a scenario by imagining a real-world support case problem. And look at this problem from a customer care executive perspective. Suppose you are a data analyst working for this superstore, and you often get requests from customer care team. Now this time, they need help identifying a specific customer ID because a customer has raised complaint about the product they ordered. But here's the catch. They only have partial information about this customer. They told you that the customer name contains the keyword Ashbrook and the last 4 digits of the order ID are 4501. With just these 2 clues, they want you to find the correct customer ID for this customer, so they can figure out the phone number of this customer ID from the another data set and personally call this guy. And your task is to use Tableau to figure it out. Take a moment to really think through this business request before moving forward. And now before we dive into the solution, let's try to understand why resolving this issue is important for the business. So taking care of these issues does a lot more than just fixing a problem. It eventually keeps customer happy. It also prevents them from switching to competitors. It means preventing them from churning, and shows that the brand cares about the customer, which really helps maintain a strong brand reputation. Now that we understand the scenario, what information we have, and what we need to figure out, let's move on to the solution approach. So the first step is to identify the relevant fields we will be working with. So the first field we require is the field customer name, since we are looking for the string Ashbrook within the name, and order ID to check for the last 4 digits, which is 4501. And lastly, the customer ID field, which is the final piece of information we need to report back. So these are the 3 key fields we will be focusing on in this analysis. Now before I walk you through the solution, I want you to take a moment and think through a rough logic for how you might approach this problem. Alright, let's get into it. Now if you notice, both pieces of information that we have, the customer name containing Ashbrook and the order ID ending with 4501, are both logical conditions. Let's simplify that a bit. First, let's focus solely on the customer name field. In plain English, we just want to check, does the customer name contain the substring Ashbrook? And the answer to that question could simply be true or false. Nothing in between, right? So it's a straightforward yes or no check. Similarly, when we look at the order ID, we want to check whether it ends with 4501 or not. Again, this gives us just 2 possible outcomes, either true or false. So just like the name check, this is another clear yes or no condition we can work with. Any confusion? I hope not. Once that's clear, we can go ahead and name these 2 output fields as flag 1 for the name check and flag 2 for the order ID check. Now our task is simple. We just need to find the customer ID where both flag 1 and flag 2 are true. That will be a matching record. Simple, right? Now let me show you how we can implement all of this in Tableau step by step. Once in Tableau, open a fresh sheet and rename it to Customer Support. Let's begin by creating our first flag, where we check if customer name contains the word Ashbrook. To do this, go to the data pane and click on this small drop down and select Create Calculated Field. Next, I'm going to name this field as Flag 1 Name Check. Now to perform the check, we'll use Tableau's built-in contains function. Just start typing contains and Tableau will show it in the suggestions. Go ahead and click on it to insert the function into your formula. Inside this parenthesis of contains function, we need to provide 2 things. First, the field name, in our case it's customer name, and second, the specific keyword we are searching for, which is Ashbrook. Once you have entered the formula, take a look at the bottom left of this calculated field. You will see the message, the calculation is valid. That means Tableau understands what you have written and it's ready to go. But before you hit OK, let's address 2 important questions that might be popping in your mind right now. So if you are wondering, how did I know which function to use for this task? The answer is simple. You can do a quick Google search or just ask any AI model like ChatGPT for the right Tableau function based on your use case. Now the second question you might have is, how do I know this customer name comes first and the substring Ashbrook comes second inside these parentheses? Again, easy. Do a quick search about it. But if you want to see Tableau's internal documentation, click on this small drop-down arrow on the right edge of this calculation editor. Tableau provides the function documentation right here. So for contains function, it clearly shows that the main field comes first, which is a string customer name, followed by the substring Ashbrook. So this is how you use the contain function. And if you notice, you'll also see a long list of built-in functions here. Don't let it overwhelm you. If you're curious, feel free to explore. But for practical use, it's always better to search for a function on Google based on your specific use case and learn gradually about different functions. Cool? Now go ahead and click OK to save the calculation. You will notice that the flag 1 name check appears in the data pane as expected. And also, it is a Boolean data type represented by this true and false icon. And if you're curious to see how this calculated field looks in your data, you can head over to the Data Source tab. Here you will find this newly created field listed alongside your existing ones. And it will only show two possible outcomes: true if the customer name contains the word Ashbrook, or false otherwise. Now head back to our sheet and let's start working on the second check, which is to determine whether the order ID ends with a specific number, in our case 4501. Just like before, we'll again create a new calculated field using a function that checks the ending of a string and use it to build a second logical flag. So let's get into it. First, create a calculated field and this time name it to flag2 order ID check. Since I already looked it up on Google, I found that Tableau provides a built-in function called ends with, which is perfect for checking whether a string ends with a specific value. Here too, you can refer to this quick documentation in the calculation editor to understand how ends with function works. So just like contains, you'll need to place order ID field as a first argument and the substring 4501 as the second. And finally click OK to save the calculation. Now both of our Boolean flags, one for customer name check and one for order ID check, are ready and available in the data pane for further analysis. We are all set to combine both flags now and use them to arrive at the final answer we are looking for. Now as you move forward in your Tableau journey, you will find there could be multiple ways to get the answer we are looking for. But I'll go with the simplest approach, one that you are already comfortable with. So let's begin by adding the required field to the view one at a time. First, I'm dragging the customer name field onto the row shelf, and if you see a warning prompt like this, just choose add all members for now. Next, drag order ID field next to the customer name on the row shelf. Again choose add all members if prompted. And finally, add all the customer ID field to the row shelf as well. So we have all three key fields lined up neat and clean. This sets the stage for applying our flags we just created and narrowing down to the correct record we are after. So first, I'm using this flag 1 name check to filter the customer name field for entries that contains Ashbrook. So go ahead and drag this name check flag onto the filter shelf. And in the filter dialog box, check the box next to the true. This means we are only interested in the names that contain Ashbrook, and click OK to apply the filter. So once the name check filter is applied, you now see only 3 customers whose name include Ashbrook are appearing in the view. Similarly, let's now apply the second flag, which is order ID check, to filter for the order ID that ends with 4501. So drag this flag 2 onto the filter shelf, and again in the dialog box, check the true box. This ensures we are only seeing records where the order ID ends with 4501. And click OK to apply the filter. And now our view is only showing the rows where both the conditions are met, therefore narrowing it down to the exact customer we are looking for. And there we have it. So the customer name is Aaron Ashbrook and the customer ID is EA14035. Now you can forward this customer ID to the support team so that they can look for this customer ID in their own database and search for his personal phone number and resolve the issue directly with the customer. And that's how you can create Boolean calculated fields and use them together to filter data precisely based on your specific use case. Now let's move forward and explore the second type of question that we can solve using calculated fields. If you have understood this one, you will find the next example even more straightforward. In this case, the business ask is quite simple. We just need to report the minimum and maximum sales for each product subcategory. Seems easy, right? I'll show you 2 quick ways to approach this problem. The first method uses Tableau's built-in aggregation feature, which we have probably seen in earlier videos. In the second method, we will create simple calculated fields for minimum and maximum sales, just to demonstrate how these calculated fields work and how Tableau aggregates them based on the level of detail in the view. Both are easy, but the second one gives you more control and deeper understanding of the calculated fields. But before we jump into how, let's take a moment to understand why this question even matters. Mostly, it helps you get a sense of sales spread within each subcategory. By spread, I mean the difference or delta between maximum and minimum sales. And if there's a big difference between the lowest and highest sales, it could mean that some product subcategories are doing great while others are lagging, possibly a sign of poor product mix. So the solution here is pretty straightforward. We only need two fields to carry out this analysis: sales and subcategory. That's it. And now to get started with the visualization, we'll simply drag subcategory field onto the row shelf and then drag the sales field onto the ABC text mark on the canvas. And then from the sales fill in the marks pane, change the aggregation to minimum. This will display the minimum sales for each subcategory. And to show the maximum sales, simply drag the sales field again onto the ABC text mark on the canvas, and then in the marks pane, change its aggregation to maximum. This way, you will see maximum sales displayed right next to minimum sales for each subcategory. So that's the first approach I mentioned, using Tableau's built-in aggregations. Now let's go ahead and implement this in Tableau first. And once that's done, I'll show you how to create the same table view using calculated fields. Cool? Let's switch to Tableau. Once in Tableau, open a blank sheet and name it to min-max sales. First, drag the subcategory field onto the row shelf and then drag the sales field onto the text mark on the canvas. Now go to the sales fill in the marks pane and change its aggregation from sum to minimum. You can also adjust the column width of the table for better readability. Similarly, drag the sales field again onto the text mark on the canvas, and this time look for the second sales fill that appears in the marks pane, which still shows sum by default, and change its aggregation from sum to maximum. And that's it. We now have a simple data table showing minimum and maximum sales for each subcategory. You can format these numbers if you would like, for example, adding a decimal place or adding a dollar sign. For instance, minimum sales cannot be realistically 0. So if you add a decimal place, you will notice that the minimum sales for this appliance subcategory is actually $0.4, not 0. But I'll leave that part for you to explore. Alright, so this was the first way to create this table view using Tableau's built-in aggregation feature. Now let me show you how to achieve the same result, but this time using calculated fields. Let's create a new sheet and rename it to 5_CF2 min-max sales. You can choose your own naming template to name a particular sheet. You don't have to necessarily follow this naming scheme. But for clarity, I'm updating the sheet title to min-max sales using calculated fields. Now let's create our first calculated field to compute the minimum sales. Right-click on the empty space in the data pane and click on Create Calculated Field and name it to Minimum Sale Calculated Field. And inside the formula editor, I'm using simple min function and passing the sales field as an input. Once that's done, just hit OK, and there you go. The min sales CF now shows up in the data pane. Now let's do the same thing to create a field for maximum sales. This time, I'm using a max function in the formula editor and passing the sales field again. Hit OK, and that's it. Both of a simple calculated field, one for minimum and one for maximum sales, are now ready to use. The first step now is to drag and drop the subcategory field onto the row shelf. This sets up the structure so we can start using our newly created calculated field in the view. But before I actually place these calculated fields onto the text mark, I want you to take a moment to understand a few basic but important points. Specifically, how calculated fields get aggregated in the background by Tableau. So if you head over to the data source tab and take a look at these three sales related columns, the original sales field and two calculated fields we just created, let me ask you a quick question. When you drag this default sales field onto the text mark in the canvas, what kind of aggregation does Tableau use by default? That's right, it uses sum. So here's the first key point I want you to remember. When you use a raw measure like sales, Tableau automatically aggregates it based on the level of detail in the view. In our case, since we have placed subcategories onto the view, Tableau aggregates the sales at the subcategory level, and by default, the aggregation is done using the sum function. If in place of subcategory, we had the region field, the sum of sales aggregation would happen at the region level instead. Also, you can manually change this aggregation from sum to average, median, count, minimum or maximum, depending on what kind of insights you are after. For the second important pointer, let's take a look at the sales column and the minimum calculated field column. At first glance, it might look like the same field, but here's the catch. For calculating the minimum, we have explicitly told Tableau that we want this field to use minimum aggregation no matter what the level of detail is. In other words, the aggregation logic is already built into the calculated field. So unlike this raw sales field, which by default uses the sum aggregation, this minimum calculated field will use the minimum aggregation by default. So now when we drag and drop this calculated field onto the text mark, what do you think will happen? Will Tableau apply any aggregation here? Think about it. No, it won't, because Tableau recognizes that this field is already an aggregated value. Specifically, we used minimum aggregation function here, and that's why you will notice the AGG prefix in the front of minimum sales CF bill. And unlike the default sales field, where you can choose from different aggregation options like sum, average, minimum, maximum, etc., in the aggregated field, here you won't get that choice because the aggregation is already defined inside the calculated field instead. Make sense? So take a moment to really get comfortable with these fundamentals. These are the building blocks that will help you grasp the more advanced concepts we will be exploring next. Now to complete the view and get to the final output we are aiming for, let's drag the second calculated field, which is maximum sales CF, onto the text mark. And once again, you can notice the AGG prefix just like before, because this field too already contains the aggregation logic defined within it. Now you can go ahead and remove this default sales field from the view if no longer needed by dragging it out from the measures value pane, and then rearranging the columns by vertically arranging these pills to organize the layout in a way that looks like before. Alright, that wraps up this important fundamental concept and the simple business question we just tackled. Now it's time to deep dive into the next important question, which will need a bit more attention of yours. So I want you to stay focused for the next 5 to 10 minutes to understand the concept. And don't worry, I'll walk you through it in a super simple and easy to follow way. Let's kick off the next concept with a practical business question. What is the profit margin percentage with respect to sales for each region? Or in other words, we are trying to figure out the percentage share of profit compared to the total sales within each region. Basically, how much of the revenue actually translates into profit. Got the question? Don't worry, in few seconds I'll walk you through a simple calculation to show exactly what I mean by profit margin. But first, let's understand why the business would want to calculate the profit margin percentage for each region. So the finding of this analysis enables smarter investment and resource allocation by highlighting regions with high profit margins. On the flip side, The low profit margin in certain regions could point to pricing issues, high operational costs, or low customer conversion rates. These insights may help the business pinpoint exactly where improvements are needed. And the fields we need for this analysis are pretty straightforward too. We'll be using two measures, which are profit and sales, and only one dimension, which is region. Now let me show you a sample calculation for profit margin, so you get a clear idea of the simple maths behind this metric, especially how we compute it region wise. So let's imagine we've already computed the total profit and the total sales for each region. I've picked some easy to follow numbers here just to simplify the maths and help you clearly understand how this works. For example, if we want to calculate the profit margin percentage for the West region, we just divide the total profit by total sales for the West region. So that's 500 divided by 2500. And then to convert it into a percentage, we multiply it by 100. This gives us a profit margin of 20% for the West region. Simple enough, right? And in the same way, we can easily compute this profit margin percentage for the other regions too. And to create this view in Tableau, simply drag the region field onto the row shelf and then place both the profit and sales field onto the text mark on the canvas. This will give us this basic aggregated purple table. And to calculate profit margin percentage, we can try creating this calculated field using the formula we just discussed, which is profit divided by sales, multiply it by 100. Seems reasonable. So let's go ahead and implement this part in Tableau first, just to make sure everything's working as expected. First, open a blank sheet in Tableau. Since this is a sixth view, let's name it to something like sixth calculated field 3 regional profit margin percentage. Or feel free to name it according to your own naming style. So to create this tabular view, the first step is to drag this region field onto the row shelf. You'll find this region field nested under the geographical hierarchy we created earlier. Next, drag the sales field onto the text mark to display the sales values. I'm adjusting the column width for better clarity and also to create a bit more space for the next field to drop here. Then drag and drop the profit field onto the same text mark to show both metrics side by side. Now as discussed, to calculate profit margin percentage, let's create a calculated field and name it to something like profit margin percentage. Inside the formula editor, input profit divided by sales, encapsulate brackets around this ratio and multiply it by 100 for converting this ratio into percentages. And also make sure the syntax is correct. You'll see a calculation is valid message over here. Once confirmed, go ahead and click OK. Now that a calculated field is ready, let's drag this profit margin percentage onto the text mark on the canvas. And to keep the table neat, let's reorder the fields from here in the measures pane. Put the profit margin pill right below the profit and sales pill. This arrangement shows the profit margin percentage as a last column in our table. Now take a moment to pause and observe the table. Something feels off, isn't it? Let's look closer. Even when both profit and sales are positive, why we are seeing a negative profit margin percentage in some places? And even more strange, these percentages are in thousands, which clearly doesn't make sense. Percentages should ideally be between 0 and 100. So the big question is, what exactly went wrong? So you might be thinking, wait, the calculation shows as valid, so what's the issue? Here's the hint. Yes, something is wrong in the calculation itself. And this brings us to an important lesson in your data analysis journey with Tableau. Just because Tableau or any other tool gives you a result without throwing an error doesn't mean the result is always correct. Tools only check for syntax, not logical accuracy. So now it's time to break down our logic step by step and figure out where the formula needs fixing. Alright, let's start from the data itself and walk through the correct process for calculating this profit margin percentage. This will help us pinpoint exactly where our mistake lies. I initially showed you this aggregated table with total profit and total sales for each region. But to pinpoint our mistake, we need to take a step back, examine the raw data, and build the logic from there. Let's see what I mean by this. In this original orders table, do you think there's just one row representing the West region? Definitely not. There are multiple entries from the West region. To illustrate this, I've created a sample table showing how the data might look specifically for the West region, with columns like order ID, region, sales, and profit. For now, let's focus only on West region sample data and work through how to correctly calculate the profit margin percentage. So the first thing we did was define the profit margin percentage formula, which was pretty straightforward. Profit divided by sales multiplied by 100. This is the same formula we used in a calculated field as well. Now let's see how this formula plays out at the individual row level. And we have computed profit margin percentage for each product entry using this formula over here in the last column. First, let me show you how Tableau calculates the total profit and total sales specifically for the West region. So when we drag profit field onto the text mark on the canvas, Tableau by default adds up all individual profit values. It means it performs a sum aggregation. The same thing happens when you drag the sales field onto the text mark. This time, Tableau sums up all the sales values row-wise, and that's how you get a total profit of $500 and total sales of $2,500 for the West region itself. Makes perfect sense so far. But here's where things go wrong. When you drag the profit margin percentage calculated field to the view, Tableau as usual try to sum up the individual profit margins across all rows. Now remember, each of these row level profit margin is already a percentage, and individually they won't exceed 100%. But when you sum them up blindly, it's easy to cross 100% or even go into thousands. And that's exactly what happened. So instead of correctly doing the total profit by the total sales and then multiplying it by 100, which should be 500 divided by 2500 and then multiplying it by 100, Tableau first applies the formula, which is profit divided by sales into 100 at the row level, and then summed up all those percentages, which completely distorts the final result. And that's why you saw these absurdly high values like more than 70,000 percentages in the profit margin column here in Tableau. The mistake lies in where and how the aggregation is happening. So it's clear that the formula needs a slight adjustment. So instead of dividing profit by sales at individual row level, we should modify it first to calculate the total profit and total sales, and then divide those totals and multiply it by 100. And once we update the formula, the aggregation logic changes too. Now to calculate the profit margin percentage for the West region, Tableau takes the total profit and total sales and applies the formula, which is sum of profit divided by sum of sales, and then multiply this ratio by 100. And this gives us the correct result of 20%. So once we drag this newly created calculated field onto the text mark on the canvas, Tableau will now display the correct profit margin percent for each region, right? And also notice how this profit margin pill label in the measures value pane changes from default sum to aggregation, which indicates that the aggregation has already been defined inside the formula. Got it? So all that's left now is to correct the calculated field calculation and update the view to show the accurate profit margin percentages for each region. So first, instead of creating a brand new calculated field, you can right click on the existing profit margin field and choose duplicate to make a copy of it. And then right click on this duplicated field and select edit to modify the formula. Let's rename this field by just adding the suffix corrected. Then update the formula by replacing the profit and sales fields with sum of profit and sum of sales. And after verifying that the syntax is correct, go ahead and click OK. Now drag this corrected profit margin calculated field onto the text mark on the canvas and observe the difference. For instance, earlier the central region showed an incorrect profit margin percentage of around -24,000 percentages, but with the corrected field, it now displays a much more realistic figure of 8%. You can manually verify this by dividing the total profit of 39,706 by the total sales of 501,240 for the central region. Then multiply this ratio by 100, you will get the value around 8%. And finally, if you want to tidy up the view, you can remove the old profit margin percentages from the table. But I'll leave it as it is for now, just to help with understanding and comparison. Awesome! If you understood this example very well, then congratulations! You are now ready to deep dive into more advanced Tableau features. You'll soon appreciate how using aggregations inside calculated fields gives you true control over your data, allowing you to shape and transform it to fit your specific needs, especially when we begin discussing the flagship data transformation feature in Tableau, which we call as level of detail calculations. So be sure this concept is absolutely clear, and whenever you feel stuck, don't hesitate to revisit this section for a detailed refresher on this crucial topic. Cool. So that's it for this business question of computing regional profit margin percentages. Alright, let's dive back into the fun part. This time, we'll begin things off with a fresh business problem, and I'll show you how you can reuse this profit margin calculated field we just created, and also how we can plug it into a new calculated field and turn it into an insightful, colorful visualization. Ready? In this business question, we will take the recently created profit margin percentage calculated field and explore how this metric varies across different product categories and subcategories. So the goal here is to see if we can classify the subcategories into low, average and high profit margin groups and transform that into a sleek and insightful visualization. Sounds exciting, right? This kind of analysis helps the business pinpoint which product segments are high margin and which ones are low margin. It also enables smarter decisions around pricing strategies, promotions, and inventory planning by focusing on profitability instead of just sales volume. Just a quick reminder, if you've noticed, I always start by explaining why we are solving a particular business problem before jumping into the solution approach. I usually highlight a few key points around what the business might be expecting from this kind of analysis. But always feel free to think beyond my sample pointers and add your own thoughts. There's always room to explore what else the business could gain from it. Now coming back to our business question. If you read it closely, you will notice the main fields we need is the profit margin percentage that we have already created in the last question, along with category and subcategory field from the dataset. Now let's begin building a simple visualization. First, we can start dragging two dimensions, which is category and subcategory, onto the row shelf, and then place the profit margin percentage calculated field onto the column shelf. This setup will generate a horizontal bar chart that visually represent the profit margin percentage for each category and subcategory pair. So this is how we take care of the first part of our analysis. But now, here comes the slightly tricky step: classifying each subcategory into 3 segments based on their profit margin percentage. But before jumping into the logic, it's important to have a quick conversation with the business team to agree on the threshold as to what exactly defines low, average and high profit margin. For instance, one such rules could be, if the profit margin is less than 0%, we can call it as a low, call it as an average if it is greater than 0% but less than 10%, and if it is 10% or more, mark it as a high profit margin percentage. Once such logic is defined and implemented, we can use these low, average and high categories to color the visualization, which makes it more intuitive and insightful by visually separating low, average and high performing subcategories. So that's the plan for tackling this business question. Simple, logical and visually impactful. All clear? Cool. Let's hop into Tableau and start building this awesome visual step by step, just like we discussed over here. In Tableau, let's start by creating a blank sheet. Since this is a 7th sheet, I'm naming it to 7 subcategory profit margin percentage. Begin by dragging the category and subcategory dimension onto the row shelf, and next drag the corrected version of profit margin percentage calculated field onto the column shelf. This gives us a clean horizontal bar chart showing profit margin for each subcategory under its respective category. Now comes the interesting part. When you look at this colored bar chart and see the categories such as low, average and high that we want to use, ask yourself, are these categories already present in our dataset? The answer is no. These logical categories don't exist in the data. So it's clear we need to create them ourselves. So how do we bring in this new information into our dataset? Yes, if your mind immediately thought about calculated fields, then you are absolutely right. This shows that you're paying attention. So in Tableau, we are going to use a calculated field to define the logic for categorizing profit margins into low, average and high categories based on the business thresholds we discussed earlier. So let's go ahead and create a new calculated field and name it profit margin categories. And inside the formula editor, we'll now write a simple logic using if-else statements to classify each subcategory based on its profit margin percentage. No worries, let's break this down step by step. And trust me, it's pretty easy to understand as well. Just keep an eye on the image displayed on the screen for a quick logic reference. Let's first start by defining what we mean by low profit margin. Whatever I'll say in plain English, I'm just going to translate it into the Tableau syntax over here. So all we are saying, if profit margin percentage is less than 0, then call it as low. I hope this syntax is pretty clear to you now. Alright. Next up, let's define what we mean by an average profit margin. So here's how we'll frame the logic. If profit margin percentage is greater than or equals to 0 and profit margin percentage is less than 10, then we'll categorize it as average. And whatever we have written in between the if and then statements is one particular condition. So make sure you wrap this one whole conditions into the parentheses. So Tableau reads it as one complete logical block. And finally, let's wrap it up by setting the condition for high profit margin category. Just like we see in the displayed image, if profit margin percentage is greater than or equals to 10%, then we will label it as high. Simple and clean. Since this calculation is currently showing some errors, we'll fix the syntax in a moment using Tableau's format. But for now, just make sure you clearly understand these basic comparison conditions behind each label, low, average and high. Sounds good? Now let me walk you through how Tableau wants us to structure these logical if-else statements so that it doesn't throw any error. Take a look at this first block. Say we only wanted two categories like low and high. Tableau expects the syntax to look something like this. So after if, we write the condition, then followed by the label, then we write the else followed by the second label. And then we end the statement by literally writing END at the end. For example, if you want to classify sales into just low and high categories using the 10,000 as a threshold value, the syntax in Tableau would go something like this. If sales is less than 10,000, then low, else high. And then we end the statement with END. Nice and easy, right? This will give us a clear split as low and high values based on the sales threshold value. Now let's say if you're working with more than two categories, or say 4 labels. For example, Now we want to classify sales into 4 categories of very low, low, average and high. We'd go something like, if sales is less than 5,000, then call it very low. Else if sales is less than 10,000, then low. Else if sales is less than 20,000, then call it average. Else high. And we end the statement with E and D. Pause for a minute and try to understand the simple logic written over here. Once you understand the logic and the syntax, one more thing we can clearly see, that when we want to define more than 2 categories, we can simply add the else if keyword between the outer if and else statement. So for something like 4 categories, we would need to include 2 else if conditions in between, right? Now think about it. Based on a current use case where we need to create 3 labels, low, average and high, how many else if statements do you think we'll need? Exactly. Since we only have 3 categories, low, average and high, we only need one else if in our logic. And because that covers all possible cases, the final condition where we define high label simply becomes an else statement instead of another full if statement. Concise and simple. So this is the complete and final logic we will use to classify our profit margins into 3 distinct categories. Alright, now let's go ahead and update this logic in Tableau to ensure the calculation is valid and Tableau accepts the syntax without any errors. Great. Now once done, notice the calculation is valid now, and once ready, hit the OK button. You will now notice this newly created profit margin categories is listed in the data pane now. All that remains is to bring this profit margin categories onto the visualization and transform this visualization into a colorful one. So go ahead and drag this profit margin categories onto the color card in the marks pane and watch how instantly it transforms the visualization with distinct color segments, low, average and high profit margin. Pretty cool, right? Let me quickly change the color of these bars by editing this color legend over here. So instead of those basic color schemes, now I've got a smart, logic-driven way to style your visualizations, making your insights not only clearer but way more impactful. And this is just scratching the surface with calculated fields. Once you start using these logical calculations creatively, you'll truly start unlocking the full potential Tableau has to offer. So stick around, because things are about to get even more exciting in upcoming videos where we will extensively use the calculated fields to transform the data and create impactful visualizations. Before we dive into next and final problem statement, along with another fun visualization using calculated fields, I wanted to pause for a moment and observe something closely in this profit margin categories calculated field logic and try a quick hands-on activity on your own. So when we created this field, profit margin categories, the first thing I want you to observe here is that we have used a calculated field, which is profit margin percentage corrected, to create another calculated field. And by now, that should feel pretty normal to you, right? Now here's something I want you to think about. Take a closer look at this condition inside this else if statement. I've intentionally written this in a long way, but there's a shorter version you can try. Give it a shot. And here's a hint. Revisit this slide where we have discussed how to simplify conditions when creating more than 2 categories. You'll spot the pattern. Alright, let's jump into a final topic and explore how to build an advanced and insightful visual, the waterfall chart. Let's try to grasp the core idea of a waterfall chart through a business question. Here we need to analyze how each subcategory contributes cumulatively to total sales. So basically, what we're trying to do here is find a way to visualize the total sales while also showing how each subcategory adds up to the total step by step cumulatively. Don't worry if it sounds a bit abstract right now. It will make more sense as we walk through the solution together. But before we dive into the actual solution, let's first try to understand why business would even care about doing this kind of analysis in the first place. First off, it gives us a clear picture of how each subcategory is contributing to the overall sales. And secondly, it makes it really easy to spot the top performers as well as the underperformers just at a glance. Cool? So for this analysis, we actually just need two fields. One is subcategory, which acts as a dimension, and other one is sales field, which is a measure. Simple and straightforward. Now let's get a quick sense of the kind of visualization we are aiming for and how we can go about building it. So to get started in Tableau, we can drag the subcategory field onto the column shelf and the sales to the row shelf. This gives us a basic vertical bar chart. Then by sorting these bars in ascending order based on the sales values, this is how the visualization would look like. In this current visualization, we can clearly see how much each subcategory is contributing individually in terms of sales. But in this visualization, do we have any reference or indicator that shows the total sales? Not really, right? That part is missing over here. So moving on, what if we now calculate the cumulative sum of sales across subcategories? Now this is the perfect point to pause and visually understand what cumulative sum actually represents and how it's calculated in this context. So here's what is happening over here. Since this fasteners is the first subcategory in a sorted plot and there's no other subcategory before it, the first bar in the cumulative sum of sales plot simply reflects the sales of fasteners alone. That's why you'll notice the value of the first bar is same in both the original chart and the cumulative version. Now if we look at the next bar in the cumulative plot, this one represents the total sales up to the labels subcategory. So basically, it adds up the sales of fasteners and labels. That's 3024 for fasteners plus 12486 for labels, which gives us a cumulative value of 15511, right? In the same way, the third bar shows the total sales up to the envelope subcategory. So that means it includes sales from fasteners, labels and envelopes, which adds up to 31,987. And this pattern continues for the rest of the bars. And finally, this last bar in the cumulative plot represents the total sales across all subcategories in the dataset, which we've already seen before, which comes out to around $2.3 million. And that's really the core idea how a cumulative sum of sales plot is built. Now this cumulative sum of sales plot addresses the limitation we had this with initial bar chart for this visualization that we want to create. The first plot only gave us a view of each subcategory's individual sales. It didn't give us any clue about the total sales. But with this cumulative version, we now get the both. We can still see how each subcategory contributes, and we can clearly see the overall total sales represented right there by the last bar. Make sense? Looks like we are on the right track. With that said, there's still a bit of room for improvement, because while the cumulative bar plot shows the overall trend, it doesn't really make the individual contribution of each category stand out clearly. It's all kind of blended together, right? So for instance, if you take a closer look, only this portion of the last bar actually represents the total contribution of the phone subcategory to the total sales. Now wouldn't it be great if we could somehow isolate just that segment to display the individual contribution of the phone subcategory to the overall sales, which is around $330,000, and then do the same for the chairs and rest of the bars. That way, we would get a much clearer view of how each subcategory stacks up individually within the cumulative total. Appreciating it? And this final version of the plot, where we can clearly see each subcategory's individual contribution while also getting a clear view of the cumulative total, is what we call a waterfall chart. Awesome? So that's the core idea and logic behind this fantastic plot. It's simple, super informative, and definitely grabs attention at first glance. Now let's get ready and build this plot step by step in Tableau and see exactly how to bring this visual to life for our analysis. Alright, let's hop into Tableau, and the first things first. Go ahead and create a new sheet and name it as Waterfall Chart. For this chart, just two fields are all we need, which is subcategory and sales. Since the first step in our solution was to create a simple vertical bar chart of subcategory sales, so go ahead and drag the subcategory field onto the column shelf and sales onto the row shelf. Next, we want to sort these bars in ascending order based on the sales value, so just click on the first sort button in the toolbar to do that. Now before we move on, let's make a couple of quick tweaks. First, fit the chart to the entire view so it fills the screen nicely. Then, to show the actual sales number on each bar, just drag the sales field onto the text label in the marks pane and see the exact sale values for each subcategory right on the bars. Now if you remember, the next step in our process was to convert this basic bar chart into cumulative sum of sales chart. Also, try to recall that earlier we created a pie chart where I introduced you to quick table calculations in Tableau. In pie chart, we used % of total calculations from available quick table calculations. In the same way, Tableau offers another built-in quick table calculation called running total, which is nothing but another name of the cumulative sum. So to apply it, just go to the sales pill on the row shelf and right-click on it, hover over quick table calculations at the second last option in the list and select the running total. That's it. You will now see cumulative sales stacking up across subcategories. As we talked about it earlier, this last bar now represents the total sales from all subcategories combined, which comes out to around $2.29 million. Now if you're wondering why the labels are still showing the individual sales for each subcategory instead of the cumulative values, that's because we haven't applied the running total calculation to this sales bill in the marks pane yet. That's why it's still showing the original isolated sales values for each subcategory. Now here's a quick tip to help you spot this kind of issue right away. If you notice this sales bill in the row shelf where we applied the quick table calculation, a little triangle or delta symbol appears on the right hand side of the pill. This symbol means a quick table calculation has been applied because the running total is active here, but you will not observe this symbol on the sales bill in the marks pane. That's why the labels are still reflecting the old non-cumulative values. Got it? So to make sure the labels shows the actual running total of cumulative sales values, just right click on the sales bill in the marks pane and apply the running total quick table calculation here as well. And once you do that, you will notice the numbers on each bar update to reflect the correct cumulative totals just like we intended. Alright, now comes the fun part. What we need to do next is to tweak this cumulative sum chart so that each bar only shows its top portion, basically trimming off this lower portion. The idea is to make this top section appears like it's floating, and the height of this suspended piece will represent the individual sales of that specific subcategory, which is around 330k. So our mission is to find a way to isolate this top slice for every bar while hiding the rest. Sounds clear? Let's get to it. In Tableau, we can't pull this off in just one single step, so we'll break it down into two parts instead. First, what I'm going to do is to get rid of these full bars and leave behind just this horizontal mark at the top of each one. Think of it like this. Imagine you're measuring your height against a wall. When you stand straight and mark your height with a pencil on the wall, that line at the top, that's exactly what we are aiming to recreate here with each subcategory's cumulative sales point. And that type of chart where there are no bars, just marks at specific height, is known as Gantt chart. So first step here is to convert this bar chart into a Gantt style chart to get that clean minimal look with just those height markers in place. So to do that, just head over to the marks pane and click on this drop down where it says automatic, and from the list that appears, select the Gantt bar. As soon as you do that, you'll notice the bars fully disappear, and now you are left with small horizontal marks sitting right at top of where each bar used to be. Exactly what we are going for. Alright, so we have got the first step done. Those horizontal Gantt marks are in place. But here's where it gets interesting. To get to the logic, think of this last horizontal line or mark as a reference line. Now ask yourself, in which direction should the suspended bar grow? Upward or downward? If we were to stack the phone subcategory sales bar on the top of this reference line, the total height would go beyond the cumulative total of 2.29 millions. And that's not what we want, right? So instead, what we should do is grow our bar downward in the negative direction of this reference line. That way, it won't interfere with the cumulative sum and will still clearly show the individual contribution of each subcategory. Make sense? Cool. So here's the key takeaway. We want these individual horizontal bars to grow in the negative direction, and the height of each downward bar will represent that subcategory's total sales, right? But as a negative value. And that gives us a nice little hint. This is where we can use what we have just learned, the calculated fields. So we'll create a new field that simply holds the negative value of sales. Let me show you what I mean by this. Go ahead and create a new calculated field and name it as negative sales. And in the formula editor, simply type negative and the sales field. And then click OK. Now drag this negative sales field onto the size card in the marks pane to grow these Gantt marks in the negative direction. And once you do that, just like that, you will see that Gantt marks extend downwards, showing the individual subcategory sales as negative bars suspended below the cumulative reference point. Pretty cool, right? And there you have it. This final visual is what we officially call a waterfall chart. Alright, let's wrap this up with few quick formatting touches to make the chart visually appealing. Just like we have shown the cumulative sales value on the top of each bars, we can also display the actual individual sales contribution of each subcategory. To do that, just drag the sales field onto the text label in the marks pane once again, and now you see both the cumulative sales and the individual sales are clearly shown on each bar. And for that extra visual flair, let's add a bit of color. To add color, we can try dragging the sales field onto the color card in the marks pane and edit the color legend to apply the gradient of our choice. And that's a wrap on building this beautiful waterfall chart. It not only looks great, but also packs a lot of important insights. So make sure to dig into it and pull out any valuable business takeaways that you can. And if it adds value to your analysis, don't forget to include it in your dashboard. Awesome! That brings us to the end of this lecture. Make sure to practice all the key plots and concepts we covered in this video. They're the foundation for the more advanced techniques that we will be diving in upcoming videos. I'll catch you in the next one. Until then, take care and happy analyzing.